Sorry guys, I apologize for that interruption. What we were saying was this: the incenter is found by angle bisectors. The thing with angle bisectors is this: angle bisectors can only intersect on the interior of a triangle. Think about it for a second. What you're doing is you're drawing a line that splits an angle in half. There is no possible way that angle bisectors, lines that split the vertices of a triangle in half, there's no possible way that those lines can intersect on the outside of a triangle. It's not possible. There's no triangle. Please take a few minutes and try. Try drawing a triangle where the angle bisectors will intersect outside the triangle. It just doesn't happen. I split this triangle, right? Split each of these angles of the triangle using angle bisectors, right? It has to, they must intersect the interior of a triangle. They have to. What that means then is that point P must be the incenter. So an incenter must be on the interior of a triangle. It has to be. And again, you guys, this is kind of a mental exercise. I mean, just picture it. You're splitting the three angles of a triangle in half. There's no possible way that those lines, those angle bisectors, could intersect at a point that's outside the triangle. It's just not possible. So the incenter must be on the interior of a triangle. It must be, which means P is my incenter. Therefore, my circumcenter is Q. And this brings up then another interesting thing about circumcenter. While the incenter must be on the interior of a triangle, it turns out the circumcenter can really be anywhere. It could be inside the triangle. We saw a couple problems in the previous section where the circumcenter was on the triangle. When you have a right triangle, the circumcenter will lie on the hypotenuse. We did two of those problems in the previous section. So the circumcenter can be inside the triangle, the circumcenter can be on the triangle, and just like we see right here, the circumcenter can be on the outside of a triangle. Again, if I draw perpendicular bisectors, there, there, and there, those perpendicular bisectors it is absolutely possible for perpendicular bisectors to meet on the outside of a triangle. Absolutely possible. So really another interesting distinction between incenter and circumcenter. And what that leads us then to is this. Simply again, we'll set up a table to help us try and keep the differences between these 2 points of concurrency straight in our minds. So here we go, circumcenter and incenter. First, the definition. Circumcenter is the point of concurrency of what? Well, it's the point of concurrency of perpendicular, our symbol for perpendicular, right? A vertical and a horizontal line that meet at 90 degrees, perpendicular bisector. Right? That's the way you find a circumcenter. Perpendicular bisectors find their point of intersection. What about an incenter? Well, incenter is going to be the point of concurrency of what? Angle bisector. So we'll draw an angle. There's our angle, and we're looking for angle bisectors. Right? So really, really important that you keep those straight. Okay, then, distances. What do we know? Well, a circumcenter is going to be equidistant from what? The circumcenter will be equidistant from the vertices. Equidistant from the vertices of a triangle, whereas the incenter will be equidistant from the sides of a triangle. And then the last little bit, the location. Where can these points be? Well, we just saw in the previous problem, the circumcenter can be inside, outside, or on the triangle. Can be inside, outside, or on the triangle, right? The circumcenter can be anywhere. But the incenter, because it's angle bisectors, it always must be inside the triangle. Now, again, I understand, I totally get it. This is a lot of information to keep straight about these two different points, the circumcenter and the incenter, and we haven't even talked about all of them. We still have 2 more points of congruency to go in the next section. I know it's a lot of information. That's why these videos can be very, very helpful. Watch them as many times as you need to. Make yourself flashcards. If that helps you learn stuff, it's a great way to memorize information quickly. Jot all of this stuff down about the 2 and just keep going through those flashcards until you've got it down. Again, I'll say it again. If you're taking this class with me, I do expect you to know this information and to be able to keep it straight, right? The differences between the 2, I absolutely will ask you questions like this on a test. What are the definitions of these terms? Where can they be? Where can they not be? What are they equidistant from? You need to get all of this information straight and be able to know it. So what we'll do now, that we have a little bit more information about incenter, is we'll try a couple of problems, right? How can I ask you questions that really sort of involve more algebra? Yes, absolutely geometry, incenter, but do a little bit of algebra with this information as well. And we'll see that on the next page of the notes, so I'll see you there.